Alright, in this video we will be simplifying exponential expressions. In our final answer there should be no negative exponents or parentheses. When you look at an expression like this, pay special attention to any variables or numbers with negative exponents. If a variable has a negative exponent, if you see a negative exponent, it means that expression is on the wrong side of the fraction and it's going to wind up being moved. So this is the only thing with a negative exponent. This is going to wind up moving to the denominator. If it was in the denominator, I would move it to the numerator. So I'm just going to make that one change so you can see what I'm doing. So for now I'm just going to leave the 10 and the 8 and the n to the 4th power and the n and the p squared. None of those things are going to move, but the p to the negative 6th power drops down to the denominator and becomes p to the positive 6th power. Now I can go ahead and finish the problem. 10 divided by 8, we're just reducing. If you divide both of these by 2, that's going to reduce down to 5 over 4. N to the 4th power divided by n is going to be n to the 3rd power. This n, look, if I have n to the 4th power over n, that's like having n over n. So all I'm doing is canceling out one of those n's. That's why it's n to the 3rd power. Down here, it's going to be p to the 8th power. Notice I don't multiply 2 times 6, I'm adding those. So this is the final answer for number 1. Okay, now looking at number 2. First of all, I'm just going to go ahead and multiply these together. So I have 5 times 6, so that's going to be 30. Now when you multiply variables, you add the exponents. So I'm going to have b to the negative 4th power, because negative 7 plus 3 is negative 4. And then I'm going to have c to the 4th power. If it helps you to think of this as c to the 1 power, go ahead. But, you know, this is 3 c's times an extra c, that's 4 c's. Now, like I said before, you have to pay special attention when you have a negative exponent. This is going to move to the other side of this fraction. So there's an understood fraction line right here where everything was in the numerator, but this is just going to drop down to the denominator. That's why in the final answer you're going to have your 30 and your c to the 4th power that did not move, and then over b to the 4th power because it drops down. So this is your final answer for number 2. Alright, now number 3. We are squaring everything inside of the parentheses. So if you do 5 to the 2nd power, that's going to be 25. Now for the rest of these, when you have a power raised to a power, you multiply. So this is going to be x to the negative 8 and y to the 12th power. Alright, a power to a power you multiply, but you don't multiply 2 times 5 and put 10. This is 5 squared, so it is 25. Now again, I see I have a negative exponent here, so that's going to wind up moving to the other side of the fraction line. So we're ready for the final answer. The 25 and the y to the 12th power are not going to move. But that x to the negative 8th power is going to move to the denominator and become x to the 8th power. So this is the final answer for number 3. Alright, now number 4. I don't see any negative exponents, so I can go ahead and get to work on this. 3 divided by 12. Both of these are divisible by 3. 3 goes into itself once. 3 goes into 12 4 times. So that's going to reduce down to 1/4. Now n to the 0 power. Anything to the 0 power is equal to 1. So this whole thing is just equal to 1. So I really don't need to write anything down for that, because 1 times 1 is just 1. So n to the 4th power is just going to stay in the denominator unchanged. Now p to the 8th power over p squared, that's going to be p to the 6th power in the numerator. All right, these two p's are canceling out two of these p's. Look, one more time. If I have p to the 8th power over p squared, what's really happening is p to the 8th power is, let's see, 1, 2, 3, 4, 1, 2, 3, 4. That's p to the 8th power over p squared, just p times p. So what's really happening is these two p's in the denominator are canceling out two of the p's in the numerator. All right, that leaves behind 6 p's. So that's why it's p to the 6th power. Okay, now do we really need this 1 in front? No. Since we have something else here, we don't really need the 1. All right, now our job is to simplify. So if you leave that 1 there, it is not completely simplified, so you should expect to lose a point or two. Now, we're going to do problems like this in 2 stages. We have stuff on the inside that can be simplified, and then we've got this negative exponent on the overall fraction. I would recommend starting with what's on the inside and simplifying this. So basically, for a moment, ignore the fact that the -2 is out here, and then just do this problem. Now, inside of the parentheses, there are no negative exponents, so I can go ahead and get to work on this. Let's see, so the 5, there's no other number in the numerator, so that 5 is not going anywhere. I've got n to the 5th power over n. That's going to be n to the 4th power in the numerator, because this n is going to cancel out one of these n's and leave n to the 4th power. Next, I'm looking at the p to the 3rd power and the p to the 6th power. These 3 p's are going to cancel out 3 of these p's, and that's going to leave me with p to the 3rd power on the bottom. You know what? I said one more time the last time, but this, I'm going to do it one more time. So p to the 3rd power is p times p times p. P to the 6th power is p, 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 p. Like I said, these 3 p's are going to cancel out 3 of these p's. That leaves 3 p's left over, but they are in the denominator, so that's why I'm going to have p to the 3rd power in the denominator. So that's what I have once I simplify what's inside the parentheses. Okay. Now, temporarily, we ignored the fact that this was -2. But now it's time to deal with that. So I have all of this to the -2 power. So here's a principle that we can use. If you have a fraction raised to a negative power, like a over b to the -2 power, that would be the same thing as b over a to the +2 power. So you can do the reciprocal and make it a positive exponent. So that's what I recommend. So now that we have simplified this, let's do the reciprocal and then make it a positive exponent. So the reciprocal of this, I'm going to have 5p to the 3rd power over n to the 4th power. All right, and now it's squared. Now it's a +2. So now I can square everything inside. So 5 squared is going to be 25. When I do p to the 3rd power squared, a power to a power you multiply. So that's going to be p to the 6th power. N to the 4th power squared, a power to a power you multiply. So that'll be n to the 8th power. So that's it. This will be the final answer. All right, and that's a good place to stop this video. All right, we'll see you on the next video.